Hi, I go by the name Mqweba, student number 219014213. Today I'm going to be presenting my project, which is obstacle avoiding robot. Here is my student card, and I'm going to start here with my block diagram. As you can see here, I've used Arduino Uno R3 as my microcontroller. I've powered it with 5 volts DC supply, and I've used photoresistor to control the lights, temperature sensor to control the sound of the buzzer, ultrasonic sensor to detect obstacles in front of the car, servo motor to make it possible for the car to look right and on the right and on the left, LN298 motor controller to control and power the left and the right motors. And of course, I'm gonna power this motor controller with 9 volts DC supply. Here's the flow chart for the whole project. It starts here. I'm gonna power my Arduino, initialize every variable that we have on the car, assign the variable, declare LCD. That's the part of void setup, and then we go to the void loop. Here's my void loop. First, we're gonna call light and temperature. Let's go to light and temperature first, real quick. Here's what's going on here. We read the value from LDR and TMP36, and we print the value of the temperature on the LCD. After that, we test if the light is less than 300. If yes, it's less than 300, we turn on the white LED to show that it's at night, and then we print on the LCD that it's at night. If the light is greater than 300, we go this side, turn off the white LED, and we print that it's daylight. From there, we go to test if the temperature is less than 40 degrees Celsius. If it's less than 40 degrees Celsius, turn off the buzzer, and then if it's greater than 40 degrees Celsius, we turn on the buzzer. Continuing with my void loop, after we are done with these two variables, temperature and light, we go to the void loop. We read the value from the ultrasonic sensor. We test if the distance is less than 30 centimeters. If it's less than 30 centimeters, the car must stop, and it must move backward a little bit, and it stops. It must look right, read the distance on the right, and then it must look left, read the distance on the left, and then it must compare the distance on the left and right and test if the distance on the right is greater than the one on the left. If yes, it must move to the right, else it must move to the left, and then stop and move forward. Go back to the void loop. As you can see here. Here's the schematic and the PCB of my project, and here it's my circuit diagram. You can see here I've used I2C LCD. Here's my left motor, the right motor, the buzzer, and servo motor. And here is my ultrasonic sensor and the LDR. You can see that it's connected parallel to this resistor so that you can be able to read the value from this LDR. And you can see right there, it's my TMP36, which is gonna be used to read the temperature from the environment. And here it's my white LED. Okay, as I have stated before, here's my project. You can come closer. As you can see here, our LCD is displaying the temperature that is 28 degrees Celsius at the moment. So I'm gonna go ahead and increase the temperature to 40 degrees Celsius. What must happen is that the buzzer must go on. Okay, let me go ahead. You can come closer. It should be increasing now. At 40 degrees Celsius, the buzzer goes on. And then as soon as I check off the heat, it must go back to below 30 degrees, 40 degrees Celsius, and this thing must turn off. Alright. Okay, now at the moment there are lights on, so the LCD must display that it's daylight. As you can see, that it's displaying that it's daylight. So I'm gonna go ahead and switch off the lights When I do that, the LED right here in front must turn on, and it must display here that it said night now. Okay, let me just go ahead and switch off the light. As you can see, our light is on and it's displaying here that it said night. Thank you. Okay, as you can see by the wheels that the car is currently moving forward. So as soon as I place an obstacle in front of the car must move backward a little bit, and then it must go to the side where there is no obstacle. So in this case, when I put on the obstacle, the car must move backward. Okay, let's go. And then it reads the distance on the left and right, and then it chooses to go where the distance is less.